Did an interstellar object really shed its tail and then accelerate after slingshotting around the Sun? This is the unprecedented mystery surrounding 3I/Atlas, the third known visitor from beyond the solar system, and the most puzzling one yet. Recent observations reveal a combination of anomalies no comet has ever displayed. A missing tail, a sudden increase in speed, a sharp blue glow, and acceleration that cannot be explained by gravity alone. Astronomers worldwide are now watching closely as this object leaves the Sun behind and enters the next stage of its interstellar journey. A visitor from beyond the solar system. 3I/Atlas was discovered in July by a telescope in Chile. Its hyperbolic trajectory made one thing clear: this object originated outside the solar system. Only two such visitors have ever been seen before, Oumuamua and Borisov, making Atlas a rare opportunity to study interstellar matter up close. As it approached the Sun, its brightness rose sharply, and its color shifted toward a deep, electric blue. This unusual hue hinted at ionized gases or exotic materials on its surface. For astronomers, the expectation was simple: as Atlas neared perihelion, it would behave like a typical comet and produce a large glowing tail. Instead, the opposite happened. The vanishing tail. After passing perihelion, new images revealed something no one predicted. The entire tail had disappeared. Under standard physics, the region near the Sun should produce the most dramatic, powerful outgassing phase. Solar heat vaporizes ices, releases dust, and forms a tail that can stretch for millions of kilometers. But 3I/Atlas produced nothing. Astrophysical models suggest that around 13% of its mass should have been ejected to form a tail. The absence of dust, gas, or even a faint residue contradicts everything known about comet behavior. One explanation is that Atlas shed material in a way that produced no visible particles, but the mechanics behind such a clean loss remain unclear. The mystery only deepened when the object began to speed up. Unexpected acceleration. NASA confirmed that as Atlas moved away from the Sun, its velocity increased to 244,600 km per hour, or about 68 km per second. Objects typically decelerate after perihelion. Gravity demands it. But Atlas does the opposite: it's picking up speed. This echoes the unexplained acceleration of Oumuamua. But unlike Oumuamua, which showed no cometary traits, Atlas initially behaved like a normal comet, until the moment its behavior flipped. Acceleration without outgassing suggests that some other force is acting on the object. The possibilities range from exotic materials reacting to sunlight, to invisible high-speed jets, to other mechanisms not accounted for in current comet models. Why did the tail disappear? If the tail had been blown away or stripped off, some debris should remain visible. Instead, Atlas looks cleaner and more compact than before. Three leading hypotheses are emerging. 1. Invisible high-speed jets. If Atlas expelled gas at extreme velocities, the surrounding material would be nearly invisible, while still producing thrust. But the speeds required would far exceed natural comet jets. 2. Surface transformation. Perihelion heating may have removed the outer dusty layer, exposing a harder, smoother core that no longer sublimates normally. 3. Radiation pressure acting on an ultralight structure. If Atlas is unusually thin or low density, sunlight alone could push it faster than predicted, similar to a natural or artificial solar sail. None of these explanations perfectly fits all observed data, but each offers clues to an unfolding story that seems stranger by the day. The blue glow, a critical clue. Just before the tail vanished, Atlas brightened and shifted to an intense blue color. This may indicate ionized gas, metallic reflection, unusual surface chemistry, or highly energized particles interacting with solar radiation. Blue coloration is rare among comets and suggests that 3I/Atlas might possess an outer layer unlike typical solar system bodies. The timing is suspicious. The object turned blue, then lost its tail, then accelerated. A sequence that hints at a major physical transformation. NASA's updates, and the questions still unanswered. NASA and the European Space Agency state that Atlas poses no threat to Earth. In December, It will pass at a safe distance of 269 million kilometers. But official reports avoid addressing the core anomalies. Why did the tail vanish? Why is the acceleration increasing? Why is outgassing invisible? What caused the blue brightening? Meanwhile, some perihelion data remains unreleased as it awaits internal processing. This delay has sparked comparisons to past cases where unusual interstellar behavior took time to be fully analyzed. For now, only amateur and mid-range observatory photographs offer consistent visuals, and they show a compact, intact nucleus behaving in ways no comet has before. Natural or something beyond? The astronomy community is divided. The conservative view tries to fit the behavior into known comet physics, suggesting extreme sublimation, fragmentation too small to detect, or exotic volatiles. The anomaly-centered view points to repeating patterns seen across interstellar visitors. Unexplained acceleration, unusual reflectivity, missing tails or dust, unexpected brightening. To them, this pattern may indicate unfamiliar interstellar materials, new physical processes, or structures not formed through natural cometary evolution. The debate is far from settled. But what is clear is that Atlas challenges traditional models more strongly than any interstellar object before it. What comes next? As Atlas moves farther from the Sun, it becomes easier to observe. Over the next few weeks, large telescopes will retarget the object. Spectral scans will reveal surface composition. New velocity measurements will confirm whether acceleration continues. Possible fragmentation may become visible. The crucial moment comes this December, when Atlas reaches its closest point to Earth. If acceleration is still present at that time, the natural explanation becomes significantly harder to defend. By March 2026, Atlas will approach Jupiter's region, where its behavior will again be closely monitored. Data collected over the next 2 years could reshape scientific understanding of interstellar objects. Closing perspective. 3I/Atlas does not behave like any comet known to science. A disappearing tail, a sharp blue glow, and increasing velocity after perihelion create a profile that defies standard explanations. Whether the cause is a rarely seen natural mechanism or something entirely new, Atlas forces a reconsideration of long-held assumptions about what travels through interstellar space. In the coming weeks, clearer images and fresh velocity readings may finally reveal whether humanity is witnessing an exceptionally strange natural phenomenon, or the first hints of something far more extraordinary.